All right, so we have this identity here, the absolute value of A times the absolute value of B equals AB. Now, I know this is not always true, right? We're going to look for when is this true. Now, this video is not going to present a formal proof. We're merely just going to kind of plug in some values for A and B and feel it out and figure out when would this identity be true. Now, some of you may have already realized the first case here, the first possibility is that either A or B is equal to 0. Now, yeah, of course this is going to be true. The whole thing would just be zeroed out. It'd be 0 equals 0, right? Not that interesting. There are two other categories, though, that we need to check. First one here is A and B have the same sign. That is, would this be true when A and B are both positive or A and B are both negative? A and B have the same sign. So let's check. Let A equal -2 and B equal -3 and plug it in. See if it works. So the absolute value of -2 times the absolute value of -3 equals -2 times -3. Well, the absolute value of -2 is +2. Absolute value of -3 is +3. And this would equal, well, -2 times -3 is 6. And in fact, this is true. So we see here, again, this is not an exhaustive proof. We just tested a single pair of numbers. You start to get the feel that, yes, this is true if A and B have the same sign. Now, of course, the flip side to that would be, okay, A and B do not have the same sign, or I should have said they have different signs. So one of them is negative, one of them is positive, or vice versa. Do not have the same sign. So we can test this out, right? Let A equal, let's go +2 this time, and B equal -3. So the absolute value of 2 times the absolute value of -3 equals 2 times -3. This would be 2 times +3 equals -6. And no, this does not work. So we see here this top statement is true when either A or B is 0, or they could both be 0 if you really wanted it, and when they have the same sign. Right? This identity falls apart if A and B have different signs.